Hello everyone, Mrs. Sayed here. Before we get started on the lesson, I just wanted to take a moment to just check in on you guys, to check in on my students and see how you are all doing. I just want to take a moment to scale back and take a second because it just didn't feel right to jump right into a lesson, especially with everything that's going on right now in our nation. And because we're all going through it together. So I'm going to try my best to keep the lesson, pretty light because I know we're going through something right now. And I know at least we can all agree collectively that we do not and we will never support racism. And I want you all to know that I'm with you and I want you to feel heard. I want you to feel seen. And I feel this heaviness in my heart because of what is going on right now in this country. And it's a lot. It's a lot for everyone. And we are all processing it in different ways. So with that being said, I wanted to give you guys an opportunity or a safe space to kind of reflect and express how you are feeling and how you are reacting to what is going on right now in our nation. So I want you to do this mini reflection assignment that's within our lesson. And it's a very open, no pressure assignment. Okay, I don't want this to be a burden. I want it to be something that, helps us cope with what's going on. So you have a lot of options on how you can do this assignment. And so, for example, you can just write it out. You can write out how you're feeling. It can be as short or as long as you want. There's no limits, there's no restrictions, there's no requirements. You can draw something. I know there's amazing artists in my classes. I've seen your work throughout the year. So if you just want to draw anything, a poster, a comic, whatever, you can do that. You can also record yourself. You can record a video, or you can record yourself singing or rapping or reciting a poem that you created. You guys did amazing with that in the beginning of this virtual learning, so I know there's a lot of talent there. And you can ultimately create, honestly, anything you want, okay? It could be a PowerPoint presentation, it can be a flyer, it could be anything. So it's a very open assignment, and I'm not really giving you a grade. There isn't going to be a rubric for it. Once again, the emphasis on this is just so you have a safe space to acknowledge and reflect what's going on. So you basically just get credit for it. So if you hand something in, whatever it is, you'll get credit for it. And I'll keep it private, unless you guys want to share it with your classmates. So if you do have some interest that you want to share your work with your classmates or with anyone in the school, let me know, and maybe that's something we can incorporate into our next cycle. So yeah, that's basically what I have to say. I don't know the best words to use right now, but if there's anything that I can do as your teacher, if you need any type of support, just let me know. Please be vocal with me. So speaking of what could happen next cycle, if you want to show these assignments or whatever, I do want to go over the schedule for your R3 assessment. So I don't know how much you know about this yet, but you're going to have assessments on the last 3 days of school. They don't count as a final. They will count as a test grade for your R3 for trimester 3. And I just want to go over the details of that. So the details about this, so like I said, this does not count as a final. It will only count as an exam grade, but it will cover everything that you've learned in trimester 3. So basically all of virtual learning. What you really, really, really need to know, okay, is you only have 24 hours to submit it from the date it was assigned to you. So it's going to become available at 8:10 a.m. and then you'll have until 8:10 a.m. the next day. It doesn't matter if the next day is a Saturday. So if you have it on a Friday, you're still going to have until Saturday 8:10 a.m. to submit it. Okay? So it's going to start on June 12th for period 7, 8, and 9. And then you have to submit it on June 13th, that's a Saturday, by 8:10 a.m. And it's not even up to us. This is what the higher up said. And we have to lock it after the 24 hours. So there's really no way you could submit it late. So please just do it that same day. And then June 15th will be virtual day 1, which is periods 1, 2, and 3. And then June 16th will be the last classes, which would be 4, 5, 6. So essentially, you'll be taking tests for 3 classes for the last 3 days of school. So I'm sorry about that. But that's what they've decided on. That's what's going to happen. Okay? So like I said, I'm going to try to keep today's lesson light. So the topic is basically just factors affecting solvation. So remember in the beginning, well, not in the beginning, kind of in the middle of the year, when we were talking about what can dissolve in something, and I kept saying like dissolves like. So a polar thing can dissolve in something else that's polar, because like dissolves like, and so therefore a non-polar thing can dissolve in something else that's non-polar. So that's just a general rule used to determine whether solvation will occur in a specific solvent. So solvation is the process of surrounding solute particles with solvent particles to form a solution. So I know this sounds like a bunch of gibberish maybe, but here's a picture to kind of clarify it. So this is a picture of salt, the solvation process of salt, or NaCl, in water. So the reason like dissolve like, the reason that works, this is just one example, okay? So the charged ends of water molecules attract the positive sodium ions and the negative chloride ions. So if you look at our picture, okay, our chlorine ions are negative and our sodium ions are positive. I'm sorry, the heater thing just turned on. You're gonna hear that in the background, but so the positive sodium ions are attracted to the negative part of the water molecule, and the negative what did you say? Yeah, I made sense. Yeah, I did. Okay. Okay. The negative chlorine ions are attracted to the positive part of the water. I'm going to repeat myself, okay? Because I had a hiccup there. The positive silver sodium ions are attracted to the negative red parts of the water molecule, and then the green negative chlorine atoms are attracted to the positive parts of the water. So the attraction between the water and those ions are stronger than the attractions within NaCl. So that's why NaCl splits up. And so that is called solvation. That splitting up and getting surrounded by water or whatever the solvent is, the process of that is solvation. So when it specifically happens in water, it's called hydration. So the difference between, let's talk about the difference between solvation and solubility, okay? It's kind of simple, actually. Solubility is the ability of a substance to dissolve, okay, in a solvent. So it's the ability for that to happen. Solvation is just the process of that happening, okay? So it's the step-by-step science of what's happening for something to dissolve, basically. So solubility is the outcome of solvation. I hope that's clear. Whatever. Okay, we're going to talk about different types of solutions now. We have unsaturated, saturated, and supersaturated. So an unsaturated solution can dissolve more solute, and all solute is dissolved. So like, let's say you have a beaker and I added my solute to it, it can dissolve. And I stopped and then I added more of my solute, that also dissolved. So if you can keep adding solute and it keeps dissolving, that's unsaturated. So because I keep on adding it and it keeps on dissolving, it just kind of still looks the same every time I add my solute, because there's enough solvent for it to continue to dissolve. A saturated solution, however, cannot dissolve any more solute. So it kind of reached its limit of how much more you can add to your beaker. So therefore, once you add a saturated solution, it can't dissolve anymore. So if you try to add more of the solute to your beaker, you're going to see it. You're going to see little chunks and grits of it in your beaker because it can't dissolve anymore. So it's reached its limit. That is a saturated solution. And then lastly, you have a supersaturated solution. So let me explain how this works. So you start with a saturated solution. Let's say it's at room temperature. I'm at my limit of how much solute I can add to my beaker. And then I decide to take that beaker and heat it up. I increase the temperature, okay? If I increase the temperature, it now has the capability to dissolve more solute if I choose to add it. So let's say I did choose to add more solute into the now heated beaker, more of it will dissolve. Okay, and then the last step is now I cool down the beaker back to room temperature, back to where I started, and it looks the same. Okay, you don't see any chunks or grits or anything. It looks the same as from the first step. So that means it's super saturated. I did a little trick to be able to saturate it even more, and that's it. It's super saturated. Okay. So the textbook definition is a supersaturated solution contains more dissolved solute than a saturated solution at the same temperature. Okay, so picture 1 and picture 3 are at the same temperature, but picture 3 has more solute in it. Okay, because I did that little step in the middle, I heated it up. Okay. Last kind of part, okay? We're going to talk about pressure and Henry's law. So pressure affects the solubility of gaseous solutes and solutions. And you might be like, what? What are you talking about? How does gas dissolve? It's a gas. What? So an example is carbonated beverages. So like the soda that you drink, that's CO2 that's dissolved within the soda. So that's how you dissolve gas in a solution. That's just a real life example. So there's a law that we use. It's called Henry's law. This is the equation right here. And basically it says at a given temperature, the quotient of solubility of a gas and its pressure is constant. Okay? So I'm just going to show you one example problem on that. All right, here is the example problem. Using Henry's law is kind of very similar to last cycles with the diluting solutions where you had the M1V1 equals M2V2. You kind of just plug in your information and solve for the variables. So it's just algebra. So this example problem. If 0.85 grams of gas at 4 atmospheres of pressure dissolves in 1 liter of water at 25 degrees Celsius, how much will dissolve in 1 liter of water at 1 atmosphere? So, at 1 atmosphere of pressure and the same temperature. So basically them telling you 25 degrees Celsius, that's just extra information, but it is important to know that the temperature is the same. So step 1, list your knowns, okay? Your first step is to list your knowns and your unknowns, okay? So I'm going to list out the variables that are from my formula, which is S1, S2, P1, P2. So if you read the S1 and S2, that stands for solubility, and the unit for solubility is grams per liter. So based off that, I can infer that the solubility My starting solubility, or S1, is 0.85 grams per liter, because that's literally what the problem tells us. There's 0.85 grams of gas that dissolves in 1 liter of water. So that's my solubility. And it also gives me my starting pressure, which is 4 atmospheres, so that's my P1. And it also gives the ending pressure, which is 1 atmosphere, so that's my P2. So all that's left to solve is S2, my ending solubility. So you write out your, this is step 2, now you have to solve for your unknown. So write out your formula, and your textbook made the unknown red, which is good. So we need to isolate S2. In order to isolate S2, you just do basic algebra. So you multiply P2 on both sides. Your textbook wrote it out like this. If you write it out like this, it's the same thing. Okay? But let's just follow the textbook because they filled in the rest. So now that you have your formula set, you could fill in your knowns. And so for S1, they wrote 0.85 over 1 liter. If you just wrote 0.85, that's the same thing, okay? They just want to make it more clear. And then they multiplied it by P2 over P1, which was 1 atmosphere over 4. You do the math, and you get 0.21 grams per liter. If you feel more comfortable writing out the equation like this, that's how I like it, you'll still get the same answer. So I hope this was clear. This kind of problem, straightforward, very similar to the dilution problem, the dilution lesson you learned last cycle with the formula M1V1 equals M2V2. These are just formulas. You plug it in and you solve for your unknown. So that's it for your chemistry. This will be on your R3 assessment, so please take it seriously. And yeah, that's it. I really look forward to seeing your reflection assignments. And I wish you all the best. All right, guys. I will also probably hold a review conference before the R3 assessments, so keep an eye out for that. Yeah, that's it. All right, bye guys. Enjoy the rest of your day.